Hi, I'm Lisa Kobayashi. I'm a postdoctoral researcher at the Institute of Photonic Sciences, or ICFO. We're just outside of Barcelona. And here at ICFO, I work in the medical optics group under the supervision of Professor Turgut Durduran. So the main objective of the fastMOT project is to develop a multifunctional optical tomograph that's capable of deep measurements, non-invasive deep measurements in biological tissue. So by that I mean, for example, by placing a probe on the head, being able to measure deep structures in the brain. And not only that, being able to separate the signals that come from deep structures in the brain, shallower structures in the brain, and then also just the very superficial areas of the brain. That's just an example of what we might want to be able to measure in the fastMOT project. And the objectives of work package 5 is to demonstrate that finally, with the system that we are building, that we are able to do that. So fastMOT, just by design, is a very collaborative project. We are working together with the partners in the Netherlands. They are work packages 1 and 2 in helping or telling them our needs, and then they tell us technologically if it's possible or not. I've also spent a total of around 3 months in Italy working on working with the system that they have there, so working with the detector and the laser that they have there, in order to demonstrate everything I need to demonstrate in work package 5. I've also worked very closely with our partners in the UK, so that's work package 3, on developing the simulations. So we all work hard together to make the project work. So I think fastMOT is a very important project, both technologically, because we're developing a detector that contains a lot of pixels. Each of these pixels are superconducting nanowires. So technologically, it's quite an ambitious project. But I think also the full reach of the impact of fastMOT can be appreciated, particularly in the field of biomedical optics. Once we have this system working, we'll be able to work with a lot of more exotic modalities within biomedical optics. And it just opens up a lot of doors for what we can potentially work with.